Hey everybody, welcome back. And we are going to be walking through implementing Redux.js into our React application today. So Redux, as a brief little reminder, is a state management library that can be used in JavaScript applications and really anywhere. Um, you know, we're looking here at the official Redux documentation. Redux helps you write applications that behave consistently, run in different environments, and are easy to test. The big draw here is that it creates a central data store for the application state. And by having that central store, you're able to effectively compartmentalize aspects of your state, makes it easier to persist the state as it is a global object, and comes with some tools to help you understand how your application state is being updated in real time. So let's go ahead and get started. And this video is going to be as much about the concept as it is about the implementation. So, we've already come a pretty far away here, in terms of having, an application that's functional to a certain degree, right? Um, but a lot of teams use Redux to improve their workflows, to centralize how they manage their logic. And it would be a good idea for us to walk through how we would want to implement this library and this methodology. So, getting started with Redux. Redux is a predictable state container for JavaScript apps. It helps you write applications that behave consistently, run in different environments on the client, the server, natively, and are easy to test. Comes with live code editing with a time traveling debug. So obviously it's meant to be used with React, and it is tiny. In fact, the entire Redux library is basically 200 lines of code. Uh, pretty simple. So let's go ahead and get started with the installation. We are using yarn instead of npm, so we'll go ahead and do yarn install, or not yarn install, yarn add Redux, and that's automatically going to install the library and add it to our package.json here. So they have a separate package called Redux Starter Kit. Oh, store setup, creating reducers. Ooh, that's kind of cool. Let's take a quick look at what this is. React Starter Kit. What is this? Let's see here. Uh-huh. Interesting. npm install. Okay. Let's try that out real quick. Yarn add Redux Starter Kit. So let's go ahead and get some of this basic configuration set up here. The Redux docs have a vanilla example here, ... Okay, normally you create a Redux store. React Redux Starter Kit has a configure store that wraps create store. So this is basically a wrapper on top of vanilla Redux, but for the purposes of this, what we're going to do is we're actually going to just roll with the vanilla Redux. This Redux Starter Kit is something that you can work through on your own time. We're going to go ahead and work through vanilla Redux essentially. So looking here, this is a basic example. The whole state of your app is stored in an object tree inside a single store. The only way to change the state tree is to emit an action, an object describing what happened. To specify how the actions transform the state tree, you write pure reducers. So when they say pure reducer, that means that they are pure functions, meaning that if you input a parameter into that function, the function is going to return the same output every single time. There's no room for inconsistency. So That's why we don't have asynchronous API requests in Redux, because the returns from that request could be different each time. You could have a success, you could have an error, you could have an updated API instance. So when we write our reducers, when we are updating, transforming the state tree, we're dealing with just the pure JavaScript object. So here we're importing create store from Redux. Here we have a reducer here called counter. We're setting the initial state to equal simply the number 0 along with the action. Now, if the action type is increment, then we are returning state plus 1, and that is essentially updating the state. So instead of using this dot set state, what we're doing is we're returning a new updated state object. Now, if the action dot type is decrement, then we're subtracting. Otherwise, if there's no action type, then we're simply just going to return the state as it was, right? So this is a reducer, a pure function with state to action to state signature. It describes how an action transforms the state into the next state. The shape of the state is up to you. It can be a primitive, like a number. It can be an array. It can be an object, or even an immutable JS data structure. The only important part is that you should not mutate the state object, but return an entirely new state object if the state changes. So we follow the same idea in vanilla React, which is where we use this dot set state to completely replace the state object instead of mutating the state object directly by changing one of its attributes. So in this example, we use a switch statement, this, and strings, but you can use a helper. So a switch statement is just a fancy if-else statement that has if increment, if decrement, then, and then obviously has the default. So here, create a Redux store holding the state of your app. Its API is subscribe, dispatch, get state. So those are the three main things you can do with a Redux store. So let store equals create store counter. And here you can use subscribe to update the UI in response to state changes. Normally, you'd use a view binding library, e.g. React Redux, rather than subscribe directly. However, it can also be handy to persist the current state in the local storage. So here we're using store.subscribe. So we're subscribing to update the UI. And in response to state changes, we're console logging the updated state. The only way to mutate the internal state is to dispatch an action. Actions can be serialized, logged, or stored and later replayed. So store.dispatch with a type of increment returns the state plus 1, the state initially starting at 0 becoming 1. Now store.dispatch type increment changes the state to 2. 1 plus 1 is 2. Now the decrement takes it back down to 1. So in a typical Redux app, there's just a single store with a single root reducing function. As your app grows, you split the root reducer into smaller reducers operating on different parts of the state tree. So this architecture might seem like overkill for a counter app. Yeah, sure. But the beauty of it is how well it scales to large and complex apps. It also enables very powerful developer tools because it is possible to trace every mutation to the action that caused it. That is nice. You can record user sessions and reproduce them just by replaying every action. That is very nice. So now, so this is basically just kind of a list of all of the, this is all of the resources that are officially recommended from the React and Redux teams. So, should we use Redux? Before we walk into the tutorial, it's a valuable tool for organizing your state, but you should also consider whether it's appropriate for your situation. Don't use Redux just because someone said you should. Take some time to understand the potential benefits and trade-offs of using it. Here are some suggestions on when it makes sense to use Redux. You have a reasonable amount of data changing over time. You need a single source of truth for your state. And you find that keeping all of your state in a top level component is no longer sufficient. Well, I would honestly say that for what we're doing right now, Redux is totally unnecessary. However, implementing it and taking one part of the state into Redux might not be a bad thing, because in the future we might want to scale our APIs to manage their state using Redux, and so having it inside of the application might not be a bad thing, as long as we don't overcomplicate things and make it a little too risky. So let's go ahead and move on to installation here. So we've already installed Redux. So so complementary packages, most likely you'll need the React bindings and the dev tools. So let's go ahead and add those as well. So yarn add React Redux. And how do we add yarn add dev? How is it just yarn add dev? We want to add a dev dependency here. Yarn add package dash dash dev. Okay, there we go. Pretty simple. And so here we'll use yarn add Redux dev tools dash dash dev. Great. So let's go ahead and the motivation here. Well, this is probably something that we can skip over for right now. Let's take a look at these core concepts. So imagine that your app's state is described as a plain object, right? An object, so everything inside of here is attributes of an object, right? You have a to-dos attribute, you have a visibility filter attribute. The object is like a quote model, except there are no setters. This is so that different parts of the code can't change the state arbitrarily. To change something in the state, you need to dispatch an action. An action is a plain JavaScript object. So notice how we don't introduce any magic. That describes what happened. Here are a few example actions. Type, add to do, text, go to swimming pool. Type, toggle to do, index, :1. Type, set visibility filter, filter show all. So essentially you have the type here, which is just a plain string, and then that type has a payload associated with it. So this payload here is the text, or an index, or a filter. So enforcing that every change is described as an action lets us have a clear understanding of what's going on in the app. If something changed, we know why it changed. Actions are like the breadcrumbs of what has happened. Finally, to tie state and actions together, we write a function called a reducer. Again, nothing magical about it. It's just a function that takes state and action as arguments, right? Takes the state, takes the action, and returns the next state of the app. It would be hard to write such a function for a big app, so we write smaller function managing parts of the state, right? So here we have a function called visibility filter, and we have a function called to-dos. Each of them have their own updated state that is returned, right? So in the switch statement, you have multiple cases, and here we are returning an updated state. So here, right, when we're adding a to-do item, right, we're adding a to-do, what we're doing is we're adding this new object inside of this array, and we're concatenating, we're combining this array with this object inside of it with the existing to-dos array, essentially creating one array, but that array contains not just this new object, but all the other previous objects stored in that array. Okay, so, and here we write another reducer that manages the complete state of our app by calling those two reducers for the corresponding state keys. So, so essentially this is a reducer that just returns the entire state of the application. That's the whole idea of Redux. We haven't used any Redux APIs. It comes with a few utilities to facilitate this pattern, but the main idea is that you describe how your state is updated over time in response to action objects. 90% of the code you write is plain JavaScript, right? We're just updating the state of we're returning the new state based on the action type and the payload that came with it. So we have three principles here. The single source of truth, state is read only, changes are made of pure functions. So we kind of already talked about this. The state of your whole application is stored in an object tree. You don't need your whole application stored within a single store. That's just not necessary, especially if you're just doing something like creating a profile form, right? And you can just store the state of the forms inside of the component. That there's no need to literally store everything in Redux. But again, it's a system of developing, and if you if you follow it, it'll help. Right, and this kind of talks about what came before Redux. It was mostly inspired by Flux, which is a style of sending data in an application. Essentially enforcing one way data flow. Now, where is that initial tutorial here? Where is the official Redux tutorial? Didn't they? I remember I read a while ago that didn't they have some? Yes. Here we go. Okay, so they're creating a simple to-do app here, right? Well, why don't we go ahead and create a little to-do app? Right, so what are they doing here? They're adding a code. Okay. So, yeah, I guess we can go ahead and start here. So, let's go ahead and create a new file here called actions.js. So, actions are the payloads of information that describe what happened, right? And then they have a payload of information that then is used by the reducer to calculate and return the updated state through a pure function, right? So the user has an event on the front end. They are sent to the store using store dispatch, and a dispatch is an action. And the reducer is attached to a specific type of action, right? Because we have those switch statements that say, hey, if the case is this, then we want to use this reducer. And then it returns the new state object, which is, since that state has updated, it should pass down the updated state as props to all of the components that are connected to it. So as you can see, an action is literally just a plain object. It's just a JavaScript object. It has a type and it has a payload, right? Whether it's an index, a filter, it could be another object, whatever. And so here we're using something called action creators to to go ahead and actually send out and dispatch the functions. So they're functions that create actions. So in Redux, action creators simply return an action. Okay, that makes them portable and easy to test. So in traditional Redux, you would define the action and dispatch it right away. In Redux, what you want to do is you actually want to use the dispatch function from Redux, and you want to activate the function with the payload. And so this function is going to execute. It's going to return this object, and this dispatch is going to send this object to our reducers, right? And then it's going to go into the switch statement, and then it's going to say, oh, we have a type add underscore to do. Oh, okay, well, we know what to do for this type. And then it's going to go ahead and run the reducer, and it's going to return an updated state object, right? So that's what's going on here. So the dispatch function can be accessed directly from the store as store.dispatch, but more likely you're going to access it using a helper like React Redux's connect. Okay, so anyway, this is what we have here in our actions.js, right? So we have action types, right? So what we're going to do is we're going to define our action types as exportable objects, as exportable strings, essentially. Now, why are we doing that? Well, it's not really something that's necessary when you have a small application where you have a pretty clear-cut distribution of responsibility for your application. However, Redux, again, isn't really made for small-scale applications. It's made for applications that as they grow, we want to create a process for managing and updating our state that can scale along with the new features that we're implementing. So here, right, the reason why we're exporting these constants and we're going to import them is because we want to make sure that we don't have any naming collisions. We don't want to accidentally have two different types of actions that are called the same thing. And as you can recall, in a very recent video, we actually ran into this problem with our modals and our event modals, right? We had a modal that would pop up and it would render all of the events that we had from our API, and then we also had a modal that was a modal that would create an event. And as we saw from our dashboard, we were starting to have some naming issues with our handle close create event, handle show, right? So we were starting to get a little confused with all these different functions, right? That sounded pretty similar, but were manipulating different parts of the state. And so that is what this strategy seeks to mitigate. Is it wants to mitigate us accidentally naming something twice. And what's going to happen is it's going to, since we're going to import this file, it's going to run an error if we try to export a duplicated constant. So it's very helpful for that, and especially when you're working with large teams, and you have a very large application. Maybe you have 100 different action types, right? It's nice to have them all in one file because it's going to help you understand, okay, what can I not name my function, right? Like I have to think about a unique name that not only is easy to understand what it does, but at the same time doesn't duplicate any name that's already been created. So from that perspective, it is pretty helpful. So let's see, we have other constants. So we'll just work through this. Tutorial exactly as it is here. Visibility filters equals show all colon show all. Right. And then here we actually have our action creators, right? And those are the functions that we're going to execute using the dispatch API. So we're going to export a function called create to do or add to do. and it's going to include a text payload, and we're returning a action of type add to do and the text that was coming in as a parameter, right? Okay, and then let's see, we want to export function toggle to do. We're going to include the index of the to do item we want to toggle. And we're going to go ahead and export the function set visibility filter. So we're going to, we're going to set, hey, what to do items do we actually want to see here? Set visibility filter. Great. Okay, so now moving on, we're going to define some fancy reducers. And so now that we have our action creators and our actions, we can now write some reducers that would actually take the payloads of these actions, right? It would take the text of the to-do that we're adding, and it's going to combine the existing state, and it's going to add this text into that existing state, and then you're going to take that new state object and you're going to replace the old state object with that new one by returning the new state. So that will hopefully be a little clearer as we work through this, and I'll try my best to explain it as easily as I can here. So let's see, how did they name this bad boy? Just reducers.js. Yep, there we go. Okay, so what are they working through here, right? So you have a couple of different reducers here, right? So this is the initial state of the shape. This is the initial state of the to-do app, right? You have the visibility filter saying, I want to show all of my reducers. And here you have the initial state. You have two to-dos that are already pre-populated. So they're going to already show up whenever the app loads, right? So what we want to do is we want to write a reducer to handle these actions, right? So let's go ahead and create a new file here called reducers.js. So we're going to write a reducer to handle updating the visibility filter. We're setting our initial state here. So here, this is the top level of the to-do application. If the type of state is undefined, if there is no initial state, then it's going to return this initial state. So basically here, like this initial state is like blank, essentially. And if it's undefined, right, if this object can't be defined because it's not been defined, then this is going to be the initial state that is going to be plugged in. Or one neat trick is to use the ES6 default argument syntax, which honestly is a lot better. Let's do that. So they're handling the set visibility filter here, and then also here they are working through adding the to-do, right? So they're creating an object out of the initial state, and then what they're doing is they're also they're taking that initial state object, and here they are updating the attribute of to-dos, which is an array of objects. And what they're doing with this ... here is they're basically saying we want all of the existing to-dos inside of state and this other object that we're getting from the payload in the action. So basically, they're taking the state of all the to-dos, those initial two to-dos, as they were, and they're saying, comma, we are going to add this other one, right? And the text is the action payload text, and complete is by default set as false. And here, they never write directly to state. Instead, they return new objects, right? So this is pretty awesome. So this is what the reducer looks like if they kind of had everything together all in one. So they have the set visibility filter, they are adding a to-do, they're toggling a to-do, right? They're marking it as completed or incomplete. So, but this is a little verbose. I mean, honestly, this is really not that verbose. This is just three cases with a default case. Like this is in the grand scheme of things, pretty simple. But what we do want to do is we want to kind of separate out our code based on what it's responsible for, right? And so here we have our to-dos, right? And then we have a visibility filter. So perhaps we might want to separate them out because they kind of do operate completely independently. So what happens is you've made a separate you've made two separate reducers, right? So you have your to-dos app, and you have the what do you call it? You have your visibility filter operating in and of itself, and you also when it's receiving a action with the type add to do or toggle to do, it's essentially calling this function to go ahead and take in based off the action type and return a new object. So we did split it up nice and easily. And as a side note, this is called reducer composition, fundamental pattern of building Redux applications. So now let's go ahead and let's see, what are they doing here? So show all, right? So they're adding a new reducer. So they want to rewrite the main reducer as a function that calls the reducers managing parts of the state and combines them into a single object. It also doesn't need to know the complete initial state anymore. It's enough that the child reducers return their initial state when given undefined at first. So here, right? So here what we did here is we combined our two reducers into our app. And so now what we do here is we are able to assign these reducers to take action based on the action that is being dispatched. So if the action is add to do, this action is going to go through the visibility filter, and if the action type is set visibility filter, it's going to run this operation. However, if it's not, it's just going to return the state as it was before. So this is not actually going to operate, and instead this will operate, right? After the comma, this is going to have its turn, and if the action is add to do, then this is going to operate and it's going to return the updated state. So that's how we kind of we separate out our reducers, and then we can compose them together and combine them like this. So it's a little meta, but we can, it's called combine reducers. Essentially, there's a Redux utility that helps us out here and basically just combines the reducers and exports the default reducer as the combined reducer. So that's kind of nice. So we don't have to manually write out this logic. We can use this nice little utility. So that's cool. Now let's go ahead and write out this code here. So we're going to go ahead and import the combine reducers utility from Redux. That's nice. We're going to import our action types from our actions file. And so remember, we're doing this because we want to make sure that we are not duplicating any names from the actions that we have, because as we all know, once you have a sufficiently complex application, it doesn't even have to be complex, it could just be reusing the same style of adding items into state and displaying state objects through the UI, the naming can start to get a little dicey. So it's nice that we can simply have some confidence that we are not reusing any names of actions twice. So it's kind of nice. So anyway, we're going to write our reducer functions here, right? So this first function is called visibility filter. Our state is going to be show all with the action. So right here, we're writing our switch statement. We're taking in the action.type as our parameter. And in the case that it's set visibility filter, then we're going to go ahead and return the action.filter value as state. And let's go ahead and set a default operation that if this is not if it's not set visibility filter, if the action type is not set visibility filter, then we're going to just return the state as it was, and we're going to move right along our merry way. Here, this is the more important reducer. It's the to-dos reducer. We're setting our initial state to an empty array along with the action payload that we're accepting as a parameter. And we are going to add our switch statements, take the action type. If the action.type is add underscore to do, then we're going to return an array with the existing state object along with the new to do that was just added, taking the text from the action.text payload, marking completed as false, being the default option. Okay, groovy, groovy, groovy. So now after that, we're going to add a new case. What if the action type is toggle to do? So what we're going to do is we're going to map over the state. And we are going to, for every single to-do item, we're going to execute this piece of business logic. If the index of that to-do business item is the action payload's index, then we are going to change the completed value, the completed attributes in that to-do item from being false to being true. Essentially, we're flipping the value of to-do.completed. Got to figure out how to get this get those auto comments away, because it's actually really quite annoying. So we're going to go ahead and return the to do. Okay, so again, what's going on here? So if the action type is toggle to do, if we're clicking on one of the to do items to mark them as completed or incomplete, basically just to flip the state, what we're going to do is we're going to loop through, we're going to map over the state of the to-dos. And for every single to-do object and its index inside of the array, if the index inside of the state, if the index for a to-do item inside of the state object matches the index of the to-do item within the action payload, then what we're going to do is we're going to update the value of that to-do item inside of our state, and we're going to change its completed to be the opposite of what it was before. So if it was false, we're going to add the not version of false, which is true. If it was true, we're going to make it not true, which is false. And then we're going to return that new to-do object into the state marked with the updated completed value. So this is Well, I mean, it's not. It's I guess it's not overkill, but it's just a little bit more of a headache, I suppose, to explain. But here and again in our default, we're just returning the state. Now here we're going to create a constant called to do app, and we're going to use the combine reducers utility from React Redux to add our visibility filter and our to-dos reducer into one beautiful reducer family. We're going to export the to-do app object, which so that we can then import it into wherever we need to use it in our application. So next, we're going to explore how to create a Redux store that holds the state and takes care of calling your reducer when you dispatch an action. Coming up next.